Hello everyone, pay attention to the distortion you see in this game. In this video, we'll be making this effect. So let's begin. I assume that you already have a level or something on which you want to apply this effect. In my case, I have a small game on which I'm demonstrating. I'll quickly delete my existing setup and start from scratch here. Start by creating a canvas layer node. Under the canvas layer, add a color rect node as a base of our effect. With your color rect selected, click here and select the full rect. This will ensure that your color rect is covering the entire viewport. Now go to the materials tab, create a new shader material and a new shader. Double click this shader and you'll see the editor coming here. Delete everything else except the first line, which instructs that it is a canvas layer, or in other words, a 2D shader. Now the first step is to add a uniform variable for the screen texture. It is needed because the whole concept of the effect revolves around drawing the screen texture and then distorting it. After that, we add some other necessary uniform variables such as the center or origin of the effect in the UV space, the intensity, size and thickness of our effect, and the extent of the separation between the color channels. The term you see, chromatic aberration here, means the separation of color as you see in these images, where the red, green and blue channels are slightly offset from their original position due to diffraction or something like that. This will make the effect feel more stronger in our game. After that, we quickly add a fragment function. Now inside the fragment function, we quickly store the screen UV, the UV of this viewport, in two variables that we're going to use later. After that, we calculate the size of our viewport, which is equal to 1 by screen pixel size, and then we calculate the aspect, which is equal to the ratio between x and y. If your color rect is a perfect square, this aspect thing is unnecessary. But since in real screens we have different width and height, we need to adjust the effect later so it doesn't distort. Without this aspect calculation, the effect will depend on the screen aspect ratio, and therefore the effect will look oval instead of circular. Now based on this aspect calculation, we calculate adjusted UVs and the adjusted center. We basically stretch the x-axis of these values so they become circular again. After that, we calculate the distance of each pixel from the center of our effect. Now since we need to apply the shock wave only in a ring, we need to see if the distance of our pixel lies in the region slightly above and below from the radius of our circle. The radius of our circle is defined by the size variable. So if the distance is slightly more than the size or slightly less than the size, then we apply the effect here, otherwise we ignore. Now we store the actual difference of our pixel from the radius or from the ring. To visualize this, it looks something like this. So for example, this is the ring, or this is the size, or you can say the radius of your circle. The variable diff calculates how much difference it is from this line. The difference can be positive or negative. So points lying on this exact line have zero difference. But as the points move away or towards the center, the difference increases. Later on, we are going to keep our effect in this range of the difference. This difference is a very straightforward variable. To make the effect look cool, we need to apply some transformations. First of all, we will scale the difference based on the thickness, so we can control the slope of our effect. It can be as big as this, or it can be as small as this. The second thing we do is to apply the absolute function. It is necessary since one side of the difference is always negative and the other side is positive. So we must make sure that the values are always positive. And finally, we apply the power function so it doesn't look like a straight line, but instead looks something like this. Now after that, we subtract all of this from 1 to invert the calculation. It is necessary because the difference at this line was 0, so we must make it 1, and the difference elsewhere should start decreasing. That's why we subtract all of this from 1. So we get a ring that has a peak on the radius and goes down as we go away from the radius. Similarly, we calculate the direction of the distortion effect and adjust for the aspect just like we did these two values above. After that, we store the distortion based on that donut shape we calculated, multiplied by the force to control the intensity, along the direction. Now it's time to add chromatic aberration. For this, first of all, we calculate the offset. It is based on the uniform variable that we passed, which controls the offset, as well as the donut shape that we calculated here. Because we want our effect to apply only on the donut shape, or in other words, on the ring part. After that, we calculate the offsets of each channel. You see, we are sampling screen texture in all three cases, but for each one, we are applying the different offset, where the green channel is unchanged, but the other two channels have different offsets. And finally, we will apply these colors. But for the part that was outside the ring, this one, we do nothing, we just simply display the texture as is. Now let's zoom in to test the effect. If we increase force, we see that it gets a little bit different. We can increase the size and it looks like this. We can play around with different values to test our effect. Now these values will be controlled by our script. I'm not covering the script in this tutorial, but I'm going to show you the final script that I wrote for my game, which looked something like this. We are just accessing the material and we are applying the shader parameter from the script in game. Thank you so much for watching. You can subscribe for more videos.